From the given figure, find the area of the blue square. Trigonometric identities, Pythagoras theorem, basic arithmetic, algebraic operations, and formula for area of square are used to solve this question. Solution. Label points B, C, D, E, and G. Let angle DGE equals theta. Join line CG. This implies that angle CGB equals 135 degrees minus theta. Let the length of the blue square be equals to x, which equals to line CD. Line CD equals line DG. This is because opposite side lengths of a square are equal. From right triangle CGD. Using Pythagoras theorem, the square of line CG equals 2 times the square of line CD, which equals to 2 multiplied by the square of x. Take the square root of the equation. We have that length of line CG equals x times the square root of 2. This follows that from right triangle DGE, line EG divided by line DG equals cosine theta. It implies that 5 divided by line DG equals cosine theta, which equals to 5 divided by x. We call it equation 1. Consider right triangle CBG. Line BG divided by line CG equals cosine 135 degrees minus theta, which equals 2 divided by x times the square root of 2. We call it equation 2. Divide equation 1 by equation 2. It signifies that 5 over x divided by 2 over x times the square root of 2 equals cos theta divided by cos 135 degrees minus theta. This implies that 5 over x multiplied by x times the square root of 2 equals cos theta divided by cos 135 degrees minus theta. This implies that 5 times root 2 over 2 equals cos theta divided by cos 135 degrees minus theta. 5 over root 2 equals cos theta over cos 135 degrees minus theta. Cross multiply. 2 times cos theta equals 5 times cos 135 degrees minus theta. Using trigonometric identity. Root 2 cosine theta equals the sum of the product of 5 times cosine 135 degrees multiplied by cosine theta and 5 times sine 135 degrees multiplied by sine theta, which equals to the sum of 5 negative over root 2 times cosine theta and 5 over root 2 times sine theta. This implies that root 2 times cosine theta equals 5 times, in bracket, sine theta minus cosine theta, all divided by root 2. Cross multiply and we have that 5 times, in bracket, sine theta minus cosine theta equals 2 times cosine theta. Five times sine theta minus 5 times cosine theta equals 2 times cosine theta. Combine like terms. This implies that 5 times sine theta equals the sum of 2 cos theta and 5 times cos theta. which equals 7 times cos theta. Divide the equation by cos theta. This implies that 5 times sin theta divided by cosine theta equals 7. Also, divide the equation by 5. It follows that sin theta over cosine theta equals 7 over 5. By trigonometric identity, sin theta divided by cosine theta equals tan theta. This implies that sin theta divided by cosine theta equals tan theta, which equals to 7 divided by 5. We call it equation 3. This implies from right triangle DGE. By Pythagoras' theorem, the square of line ED equals the square of line DG minus the square of line EG, which equals to the square of x minus 25. Take the square root of the equation. Hence, length of line ED equals the square root of the square of x minus 25. By trigonometric identity, line ED divided by line EG equals the square of x minus 25 divided by 5, which equals tan theta. Hence, substitute equation 3. This implies that the square root of x squares minus 25, all divided by 7 equals 5 divided by 5. Cross multiply, we have that the square root of x squares minus 25 equals 7. Take the square root of the equation. X squared minus 25 equals 7 squared, which equals to 49. Combine like terms. We have that x squared equals the sum of 49 and 25, which equals to 74 square centimeters. Therefore, the area of blue square equals 74 square centimeters.